Hi students, this is MC sir. Today we have to discussing one small concept of free body diagram. Okay, before this concept, so I can give that one small instructions for you. Everyone you have to follow. Every student you have to subscribe and give the comments and like after this class. Okay, so let us start our class. Free body diagram. Free body diagram. First we have to identify that short form of free body diagram, FBD. Free body diagram, short form FBD. What is the use of free body diagram? Here, free body diagram is used to explain that higher order thinking problem with his high techniques, and it is used to find out net force acts on a body. Net force acts on a body. Okay, so just we can identify that some important points during draw this free body diagram. So free body diagram can follow these four steps. Okay, compulsory. Otherwise, so we cannot calculate that net force. So what are that four steps you have to follow? So first one, acceleration of system. Acceleration of system constant. Acceleration of system constant. Then NLM valid for the system. Okay, so NLM valid in this system. Okay, so NLM means Newton's laws. So here how many laws are there? Three laws. Newton first law, second law and third law. What is the use of Newton's first law? So Newton's first law can explain that net force equal to 0 on the body. Means if a body continues in its state of rest or uniform motion in a straight line path, there is no force acts on it. Yes or no? So this is Newton's first law. There is no force means net force acts on a body equal to 0. Second formula, Newton's second formula can explain that force formula. What is the formula for force? F is equal to mass into acceleration. Yes or no? Here F is equal to ma means there is no balanced forces here acting unbalanced force. Unbalanced force produce resultant force. Already I explained this point in the previous class. Okay, here third law. Third law, Newton's third law. Newton's third law, how to define? Every action there is an equal and opposite reaction. So here also we discuss net force equal to 0 only. Yes or no? So that we have to apply these three laws in this system. When we have to apply these three laws in this system, acceleration of the system constant. Next, second one. Total mass of system represents with point mass. Total mass of system we have to represent with point mass. It is our convenient. We have to use that point. Okay, in this diagram. Okay, next to find total external forces act on a body. So how many external forces are acting on the body? We have to identify and represent that external forces with respect to x, y and z axis in vectorial notation. Okay, understood. It is the fourth point. What is the reason? Force is a vector quantity. Due to that reason, we have to represent all the forces with respect to x, y and z axis in vector notation. Okay, these four steps we have to follow for drawing that free body diagram of the body. Okay, are you understand? So first we have to discuss one small example problem. If a body is at rest, on horizontal surface, if a body is at rest on horizontal surface, now we have to find that acceleration. Body is at rest on horizontal surface, acceleration of the system equal to 0. Acceleration of system is equal to 0 means, okay, so what is the net force? Net force equal to 0. But how many forces are acting on this body means two forces. Okay, one force is possible due to the contact. One force possible due to the contact. Another one, gravity. Okay, so now we have to follow these four steps. Acceleration of system constant. Okay, so next one, total mass of the system we have to represent point mass. Free body diagram for this body. Okay, point mass. Now represent how many forces acting? Two forces, one normal, another one weight of the body. W equal to mg. Okay, normal acts in vertically upward direction. Weight of the body is acting vertically downward direction. So W equal to mg. Acceleration of system A equal to 0. Mass of system we have to represent point mass. Here normal and weight of the body we have to represent with respect to y axis. Understood? So fourth point we have to identify here, draw external forces with respect to x, y and z axis in vector notation. Okay na? So we have to follow that 4 steps when we have to draw that free body diagram. Okay, this is one example for you. Another example I can give for you. So it is complicated only. Example 2. If body is accelerating, okay, now we have to observe this body. Here body accelerated, so its acceleration A equal to constant. Acceleration A equal to constant. Okay, acceleration A equal to constant in which direction? Horizontal direction. Don't forget, acceleration we consider along horizontal direction. Now draw free body diagram for this condition. So first, free body diagram can follow 4 steps. Acceleration of system constant. Okay, so first condition applicable. Second condition, total mass of system we have to represent point mass. Total mass of system we have to represent point mass. Now here represent that direction of forces. One force possible due to contact, that force normal. Another one, weight of the body, W equal to mg. Okay, but here we are getting that acceleration due to unbalanced force. Okay, one force, applied force, another one frictional force, represent that forces. Okay, so here draw that external force with respect to x, y and z axis. Yes or no? Here how many axes required for us? Okay, 2 axes required for us. 2 axes, x axis and y axis required. Applied force acts along positive x axis. Frictional force acts opposite to applied force. Normal force acts vertical direction along the positive y axis, and here weight of the body acts vertically downward direction, W equal to mg. Okay, understood? Do you have any doubt? No doubts for you. Okay, it is the explanation for that free body diagram. Okay, students, do you have any doubt? No doubts. Next, I can give some examples for you. In our textbook, they given one car accelerated on surface of ground. Okay, on surface of ground. Okay, so here it accelerated. Acceleration we have to represent in which direction? Horizontal direction. How many external forces acted on this body? So here one contact is there. So normal force acts upward direction. Another contact. N2. Number of contacts can represent number of normal forces act on the body. Yes or no? So we can represent 2 normal forces. One is N1, another one N2. Next to weight of the body always acting downward direction. W equal to mg. Next here car applied one force, forward force. That force applied by car only. Okay, next frictional force. Frictional force is acting opposite to the motion. This force provided by roughness between tires and surface of ground. Okay, frictional force always oppose that applied force. Okay, so it is the free body diagram for this condition. Okay, do you have any doubt? No doubt. So draw that free body diagram for this condition, FBD. So total mass of car we have to represent M. How many forces acting? So total 5 forces. One force, applied force F. Another one, frictional force. Two normal forces are acting. How many? Two normal. We have to represent like that. N1, N2. So one force acting downward direction. W equal to. So here W equal to mg. Okay. So applied force acting along negative x-axis. Frictional force is acting along positive x-axis. Here N1 and N2 represented in vertically upward direction. Weight of the body represented vertically downward direction. Yes or no? So we have to follow these points for draw that free body diagram. Okay, students, do you have any doubts? No doubts. Okay, one more example I can explain for you. Here example. One body hanged from rigid support with the help of string. Okay, here just identify here body is at rest. Here body is at rest. At rest means acceleration of the system how much? 0. Acceleration of the system equal to 0. Then how many forces are acting on this body means 2 forces. One force acts on vertically upward direction. That force provided by string. String provided force is called as tension. Yes or no? Next one, due to the gravity, body experienced one force. That force W equal to mg. W equal to mg. So here tension and weight of the body both are same forces but acts on a opposite direction. According to Newton's law, every action there is an equal and opposite reaction. Net force acting on a body, how much? Net force is acting on a body, F net equal to 0. F net equal to 0. Represent T minus mg equal to 0. Therefore, tension equal to weight of the body, but direction opposite direction. Okay, na? Here tension and weight of the body acts in opposite to the direction on a body. Okay, so these all are examples for free body diagrams. In examination time, they will give these conditions. So you have to draw properly this free body diagram. Then you have to follow these 4 steps. Okay, students, bye. So students, don't forget you have to subscribe and give the comments and likes our class. For next class also we have. For next class, do you want means we can subscribe.